My name is Tatiana. So I'm working at Mott MacDonald, and I'm a senior digital designer there. And this year, I have joined the board of organizers of Digital Users Group New Zealand. The organizers include Amadeo, Maria, Anton in Wellington, Michael, and Monica. So about our events, how can you find out about them? So we always post about new events on Eventbrite. And if you have participated in one of the events, you will get notified about upcoming ones. We also have a YouTube channel. So that's where if you missed a session or want to rewatch something, you can always find the recording after our sessions. So this year we already had 3 events. So all of them have been recorded, and they covered a broad topics from artificial intelligence in architecture, engineering and construction industry to BIM data, as well as BIM bits have presented on one of our sessions as well. And so all of these recordings are available. We also have a LinkedIn group. That's where if you join, you will receive notification as well on upcoming events and will be able to connect with our community. So the sponsor of today's event is Mott MacDonald. So thanks to Mott MacDonald for all the pizza and the snacks provided. And the venue is sponsored. The venue is sponsored by Word and Money in both Auckland and Wellington locations. All right, so now to speakers. So today we have 2 speakers, both from Mott MacDonald. Our first speaker is Alex Bogdanova, a principal sustainability advisor at Mott MacDonald. Alex is a leader in sustainable and data-driven design. She uses parametric tools and evidence-based methods to create optimal solutions for urban and architecture challenges. She works across architecture and engineering to deliver integrated designs that perform well in both indoor and outdoor environments. All right, now off to you, Alex.
Thanks, Tatiana. Hi, everyone. Please let me know if you have issues hearing me.
All right,
I think we did some
sorry,
tests.
Alex, just a moment. I'll click to start. Oh, I think I need to do it from there. Anton, are you able to start the recording?
The recording is already on.
All right. Oh, yeah. Right, sorry, Alex, you can go on.
Thank you. I'll share my screen. So this presentation is a bit of a follow-up to another presentation that you've seen earlier this year, or you can see the recording, as Tanya just mentioned earlier, about visualization and interoperability with BIM modeling for presentation purposes. But that presentation was quite technical and more into tools rather than here we would just give an overview and a bit of background how this project started. So as a sustainability consultant working with architects quite a lot, we do face a few issues. And on the left, you can see this beautiful architectural design. I'm not going to point in the specific projects, but full height window to wall ratio on west and east orientations, no shading, no facade performance, single glazing, and the client asked us to deliver a net zero building. It's not all possible just in words. You need a collaborative approach to achieve certain outcomes, and quite often they conflict between each other. So in the industry, we see quite a lot that there is low priority for high performance, for quality spaces from the efficiency and productivity perspective, not just aesthetics. And this is led by multiple reasons. And as we see, a big one of them is a collaboration between different disciplines. And it also led because of the software that we're using, that the software is not connected to each other, and all disciplines working separate without really combining the results and looking at the compromises that we have to find between the disciplines. And as an outcome, this goes to greenwashing, information misuse, and the poor performance. So working in this space, we thought, what can we do better and how we can link these bridges. Sorry, I think I dropped the slide. What's the better process to make it possible? So we want to be able to choose multiple parameters and analyze them at the same time. We want to see the results and make it more visual and clear, because not everyone can see the spreadsheets and understand straight away what does this number mean. It needs to be quite easy to digest for all disciplines, no matter on the experience. And that's how the project started. I think last year, with support by Tanya and digital developer Chauvet from our Auckland team, we set up this tool. And in a nutshell, the idea is to have something for early stage, for concept, or maybe sometimes for detailed design when you have multiple parameters to work with. It has to be usable by multiple disciplines, not just sustainability. We want structural engineers, facade, acoustics, everyone who work in Grasshopper environment or maybe Dynamo environment in the future to be able to use it. And the indirect benefits and users would be other teams, team leaders, clients, architects who would benefit from this information. As a positive outcome, we would hope to achieve a better performance, reduce upfront carbon, reduce universal urban heat island effect, improve well-being, but also such outcomes can benefit even to projects and the delivery. We can potentially reduce the amount of changes and variations on the project if it's all reviewed early on. So a few parameters that we could analyze, and it doesn't have to be restricted, it's just the most visual and easier to describe example. We can look at the facade performance, window to wall ratio, specification of glazing and solid elements, different variation of shading, and how all of this impacts carbon, heat gain, well-being. Do we maintain or reduce the views outside? But again, this is just example. It can be done for structural loads. If it's timber structure or steel, depending on the size of the grid, we would want design teams using different tools to review all of the information together. From technical perspective, if we look in the process, generally the information come to our site from Revit. It can be also done in Rhino, SketchUp, any 3D software. Typically, we bring this information into Rhino because all of our analysis happens in Grasshopper. And now also this space evolving quite quickly. And pollination as part of Ladybug Tools software creates a better link from Revit to Rhino for software for engineering analysis, and then from Rhino and Grasshopper and Ladybug Tools using Nodebox, which you will hear about in the next presentation. All of this helps us to run the analysis, but the main part of our scope is this Building Optimiser, so how to present this information, because no matter what we do in the background and how many simulations we do, if we don't translate this information clearly, this is not going to be used and helpful. So the point of Building Optimiser is to translate complex solutions and ideas into something simply digestible. This is done using Speckle and currently Streamlit, and information can be presented in Mott, the software, the web interface created by Mott MacDonald. The space is evolving quite rapidly, and even within a year of working, this diagram changed quite a lot, and I see it happen. It's changing in the future as well, so it's not a static model. We will continue progressing as we go. This is just an example of the dashboard, but I will go in details just in a minute, showing you it live. We have the space for parametric optimization and then for 3D previewer. But let's get back to this in a bit later. So what do we get out of this? We do optimize our design. We start looking at this early on and we improve the outcome, well-being, operational cost, hopefully capital cost, because quite often if we reduce upfront or embodied carbon, we reduce the cost as well. Because if you have less shading and it's in an appropriate place, you have to pay less for it. Of course, if we find out somewhere later during the stage that design is not compliant with construction codes and thermal performance is not compliant, the design team has to go and make some changes. If we start testing early on, this won't happen. So it means there are less changes and variations. So we're reducing the design process. We can review more options. We can analyze multiple scenarios rather than just running simulations independently one by one. And finally, we're improving and enhancing collaboration. We want design teams to talk to each other and review their competing priorities together. We've done already a few case studies, and as an example of one, we compared to the current, because it was an existing building, and we changed the shading strategy because it was a combustible facade. So we had to replace the whole shading system. Compared to the base case, we improved thermal comfort by 20%. We reduced the summer radiation by 30%. We improve the quality of views by 60% and reduced glare. And as you can see that, for example, glare and views would compete each other. By increasing views, you generally would increase glare. But because we could manage it all together in one parallel line, it provided quite a good outcome. Now, let me show you how it works. If we log into Speckle within our dashboard, because I've done quite a few projects already, I can select some projects that I ran before. So let's, for example, go into Hobart, and here one of the scenarios that we ran. It takes a few seconds to load, and then I can preview the parametric optimization outcome in numerical way. Sorry, I didn't select it. Okay. And we start in from large to small. So we have about 100 to 200 simulations, depending on the project, but that's been kind of an average. And we can select what we want to preview. We can either remove elements from the top bar or just drag and drop it outside. For example, I know that I don't want to look right now to radiation. And daylight is already pretty good, so it's not that very important for me right now. And on the left, I have all of the inputs. So it's different shading, angle, depth, and on the right, it's output. If I'm an architect, I generally would go from inputs because they want to see the geometrical part. As an engineer, I would prefer to go from the outputs because I want to achieve certain performance. So let's go from the outputs, and we want to maintain ocean views. We, at the same time, want to increase the amount of compliant areas with glare. So we dropped to 15 scenarios out of 216, which is still a little bit too much. So let's maybe reduce some radiation as well. And now we have only 5. Okay, that's fine. I select the filter, And then once it's saved, we go into model comparison. And in the model comparison, we can select and look at 2 different geometries. And each results will be populated below. Again, it takes a few seconds to run. And while it's loading, again, this is very live and evolving product. We update changes pretty much with every project. Once we have ideas, once we see that something probably didn't work or could work better, it's get added. And currently, it's quite minimalistic and I would say not personalized dashboard. We would like to enhance it next year and bring some Mott MacDonald branding, because that's our product that we can sell to other clients, and they can log in and look at the results from their side. They don't need to have to look through a boring report. Everything is available online. So now we have our results. So we analyzed only a couple of rooms, and we can spin everything around. And actually, in the updated version, we will have the function that if you move one room, the second view moves as well. You can see all of the inputs at the top and all of the outputs at the bottom. And you can see the average radiance, for example, summer radiance is pretty similar. In winter, it's significantly reduced in one model compared to another. And depending on your priorities and what you want to achieve, you can narrow down your scenarios this way. So that's in a nutshell the tool. Again, we would be happy to test it on multiple projects and see how it works, and if everyone has any suggestions. And for now, I'm open to questions or pass on to another speaker.
Thank you, Alex. Does anyone in the audience would like to ask a question? So maybe one from myself. So I wanted to ask about like when you, if you actually use this dashboard on project where you presented the results to clients, in how did the work go between the engineer showing the results in these dashboards, and whether like apart from showing what has been saved, whether there are other benefits that has been achieved in this way.
Thanks, Tanya. I think the biggest winner for us was when we were talking with a couple of different architects showing this dashboard, that they felt like they participating in the engineering side, because quite often if it's done in isolation, engineers give the results and don't really communicate different options to architects because there is just too much to talk through. But here we could collaborate together with client architects, engineers, and agree what's the priority and how to prioritize things. So back to the beginning, the value of it is that we enhance in the collaboration, and the whole idea of integrative design becomes possible.
Thank you, Alex. Does anyone else have anything to ask? No?
I have a quick question.
Maybe someone from Wellington?
Yeah.
Yep.
So just around the iterations, you said that there was 200 or so iterations for a project. Are they all done prior and loaded in? So then when you're having a session, that is preloaded data, or is there stuff happening on the fly as you're looking at that?
Yeah, at the moment, it's all preloaded and done. We just set up on a separate computer and it runs. And then by the time we have a meeting, it's all prepared. But we do talk about that because we collect all of this data, we have so much information that it also creates an opportunity to reuse this information in the future for some machine learning. So maybe at some point, we don't even need to pre-run it. It will be like a rule of thumb, which will take a little bit more time because we just need to run more of these simulations for different climate and locations, but it's a direction in that approach.
Hi, Alex. And one more question from Wellington, which is, so it was really cool to see you using speckle as the geometry model as the output of this. Does that speckle model then get used downstream, or is that sort of the end for it and you pivot off of that?
I'm really sorry. I'm not sure I can answer this question. And unfortunately, Shuvei, who is our digital developer, he is off sick right now. So maybe can I just get back to you with the answer?
Thank you very much.
Right. Well, thanks, Alex, a lot for your presentation. And for anyone who would like to connect with Alex, there is a QR code and a link to her LinkedIn. So you can use either the link provided or the QR code. And yeah, so now I'm gonna jump onto our next presenter. So Mirco is going to be presenting next. He's a technology enthusiast and expert in architecture, engineering, and construction industry. Mirco has 18 years of experience in design, manufacturing, and construction, and he knows how to use computation, software development, and agile methods to transform the way we design, build, and operate buildings. He works closely with clients and stakeholders to deliver customized solutions that meet their specific needs. He's always exploring new possibilities in innovations in parametric modeling, automation system, and software solutions. Off to you, Mirco, and maybe if you can also present William as well.
Yeah.
Thank you.
As you say, I'm not alone. There is Will. Will is on the presentation at some point to do a live demo of Nodebox, and so let's share the screen with the presentation. Okay, so hi everyone. So we are presenting Nodebox, that is the toolbox for computational engineers for MacDonald, and is our internal custom libraries for Grasshopper and Dynamo. So what is the problem that Nodebox try to solve? As Alex mentioned previously, most of the time we deal with decentralized problem or lack of reusability and dissipation of knowledge. So even internally in big company has MacDonald, we tend to work in a separately project and teams, and the communication is not often working well, and so the reusability of tools or definition doesn't happen. And so with Nodebox, what we try to solve is these centralize and collaborate in one tools that help us to encourage reusability across the projects and different teams in different departments. But also, and even very important, is try to centralize the knowledge and don't lose them if someone leave the company, or across different projects maybe we forgot some steps, and we try to document it as much as we can and retain these our internal IP. So what is Nodebox? Nodebox, as I mentioned, is our custom library for Grasshopper and Dynamo, but more important is an inner source project. So what does it mean? Is an open project, but internally MacDonald, and this means that everyone can collaborate. It doesn't matter the level of knowledge that you have. It can be a developer, it can be a project manager. The important that is, you come to us with an idea, and the idea is that you want to try to automate something, obviously in the space of computational design, and we try to embed this information or a process in custom component that you can use it. So what we try to explain the brand of Nodebox is that we believe computational designers are a core part that need to be plugged for every project from the beginning. And our mission is to inspire a new mindset aiming to accelerate standardization and repetition. The vision is be obviously more efficient on project and retain our intellectual properties across different projects. So the idea at the base is that Nodebox is our visual scripting tool for Dynamo and Grasshopper. The value that we are trying to bring is standardize as much as possible, quality of the code and their usability, and have and give the possibility, to learning along the process of how we when we develop different node, but also learning from the experience of other teams on improving the value of the tool, and this is also the collaboration. The promises are that at the level of tool is we have a quality assurance. At the level of people, that we try to give more time for our computational designer to have think better solution and design better workflow. Project promises, we are more effective on project and try to deliver it faster. And business process, we succeed together because it's an inner source project. So everyone that is collaborating make the project working better and performing even better. So the spirit of the project is inner source as a cradle, as we just mentioned before, because it's an inner source project. Yeah. So who are the target users? Because it's very tailored for computational designers, obviously, our target are digital engineers or digital designers that they want to expand the workflow with repeated tasks that they often found during workflow processes that they develop, but also developers, because are the one that they help on expand the library, review the library, and keep it, the library alive. And also we are looking in the future to expand the library for clients, and so give the possibility to communicate with internal teams using Nodebox and sharing data or any kind of information in a more seamless way and in a more collaborative way. So what at the moment user benefit from Nodebox is an infrastructure that allows MacDonald people to develop custom tools internally, and so all the framework around to create custom tools based on our standard and a process of review and check, and assuring our customer that obviously are at the moment internal, that we go through a QA, a QC process, and every node is reviewed by specialized SMEs. We retain our IP, so the node retain knowledges that we learn from project, and we keep expanding some of these nodes based on what we learn from a new project or from new teams. We connect with Moata, that is in particular with Moata Carbon Portal, that is this service for carbon footprint calculations. And another important point, we are measuring the utilization of Nodebox. We are able to capture when Nodebox is used by our users, and understand which node are used, how many times, and on which type of project. The quality is we are following our internal digital our quality standard that are collected in our digital solution playbook. We are expanding, and we are trying to grow a community, and so we have different channels where we communicate the project. We have a team channel, Viva Engage, formerly Yammer, and a web page and a GitHub, and also we connect with different services like Microsoft SharePoint, or for example Moata Carbon Portal, and the idea is to expand even more in the future. This is our ecosystem at the moment. So you see Nodebox in the middle, that is stored in GitHub has our space where we develop and we manage the deployments. Nodebox obviously extend for specific plugin like Grasshopper and Dynamo, but also expand the capability of Grasshopper and Dynamo with third-party services that you wish to see a test later, and with Mott as well. Plus, we are able to connect with internal apps or be used in internal apps, and probably you saw Nodebox in the presentation of Alex before. And the idea is also to bring some function cloud operation from the cloud. We already made some tests, and so we are in the process to implement it. As I said, we want to build a community, and is a project that survive and lives around the community because it's an open source project, and we need feedback, constantly feedback, and people tested. And so we have these 4 channels: the Nodebox web page that is an internal web page, and you see it. A team channel where everyone can communicate if there are bugs, any issue or feedback, and also we share weekly post on new stuff on how the project proceeds. Viva Engage, where we just share our post, and of course GitHub, where we keep track of bugs and issue that we need to develop, and is all the process of development that we have. So yeah, let's get a little bit techy right now, because Nodebox is not just a custom library, but is also a system, an entire infrastructure to distribute and distribute the packages and also capturing the data. So what you see here is all our architecture to deploy, to capture the data from the definition when Nodebox is used, and how we deploy the web app. So as you can see, we have GitHub action that they automatically run and update the static web app. We have other GitHub action to deploy straight away the packages every time we create a new release in a storage that is our repository where the user can download the new release and start to test it, and plus other logic app and solution that we use to collect the data or extract information from internal database. But plus we have our GitHub action, and this is the process that we go through every time we develop a new node. So from GitHub, our developers pick a task that need to be developed, and it is a basic node, meaning it doesn't have important knowledge from SMEs, let's say structural engineers or mechanical engineers. He just pick the task and develop straight away. And after he has the solution, he open the pull request, and from the pull request we start this process of review, and then we have a series of GitHub automation to test the code that is compliance, to test the pull request is complying with our standard. And inside the pull request, we also automatize the process of create packages that can be immediately tested from our users. And when everyone is happy, we have, and the pull request is reviewed, is checked, we merge and we create what is an alpha release. The alpha release is live and be tested by everyone, and the alpha release are packages during the phase of development, and we have a cycle of every 3 months, we create a proper release. And so between that 3 months, we create alpha release that can be tested by the user and provide even more feedback. And because these packages can be used globally, we can receive feedback from different parts of MacDonald and try to integrate more feedback as possible. After the 3 months that we close the development cycle, we create a formal release that it shouldn't have bugs, but obviously, is a project in development. So sometimes we need to fix the bugs and we restart this process of development. So yeah, after that we can move on live. And so I leave the stage. Will.
Cool. All right, guys, I'll try and just do a really quick little live demo so you can see some of the stuff we've been talking about. I'm just conscious of time, so I'll just quickly share a few little things. So firstly, as Mirco was discussing before, we have the website for Nodebox. And so this has had quite a bit of work gone into it, and it states all the information both for users and for developers. So you can come on here and it provides you with your instructions of how to install. So you can go to you get started depending on if you're a Grasshopper or a Dynamo user. There's a whole bunch of instructions that if you want to start developing about how to follow those best practice that was being discussed as well. And then we also possibly the most useful part is the catalog and the library of nodes that we have. So you can come in here as a user, you can go in, and then here we've got documentation about all our different nodes in the library and what they do, additional information, key links about them, and the inputs and the outputs. Cool. What I'll do is I'll quickly hop over to my Rhino. I won't spend too much time explaining exactly what Grasshopper is. Hopefully everyone's familiar with this interface, or at least with Dynamo, which will have the exact same possibilities. But just imagine this was in your Dynamo buttons instead. So when you've got Nodebox installed, what it's going to look like, I'll just stretch out my window. So we've got our tabs up the top. So here's our Nodebox utilities tab, and here is a list of all the different utilities components that we've developed that do a whole mixture of different things. Geometric functions, connecting to spreadsheets, maths, utilities. And then we also have different separate libraries for discipline-specific functions. So we have one for connecting to the Malata Carbon portal, as we were discussing before, which is for doing calculations for embodied carbon on materials. We also have a library for doing structural functions and structural calculations. And then we also have a sustainability library for doing various different sustainability compliance checks, doing facade checks and things like that. So that's what it looks like when the user's in there. They can come along and they can grab any of these components, got them on the canvas, and then all our custom components have got this nice little pink border on them to identify them. I'll give a quick little example of what some of our custom components do, just so you can get a bit of an idea. So here's a little example building that I've got that's got a facade in it. This is one of our sustainability components here for sorting panels into a different orientation based on which way the facade is, because different facade orientations have got different compliance requirements. So I can plug my panels in and it's going to split them out into separate groups based on which way they're facing. And then they can shoot through onto some further functions to go through their facade analysis and the sustainability checks. Then down here, I've got one of our utility functions, and this was developed quite recently that allows us to connect to a shared Excel file, so an Excel file that lives on SharePoint without having to download the file locally. So just using the shared link for it. So I'll hop over to a file now. So I've got an Excel file here. So I know engineers love working in Excel. So there's a big demand to develop this. Let's say we've got a shared environment, someone's storing location. We've got some column locations in here. There's some coordinates and some instructions for our panel sizes. So I'll just go grab the file sharing link for it, come back over, paste it in. Run this component, hopefully it works. Might have some fun with some live demos. Sometimes it goes a bit slow when we're live streaming. So here we go. We've built in an authentication, so it checks that I'm on the Mott MacDonald network. Usually it wouldn't be this slow if I wasn't streaming. So I just provide my credentials, and it's run. And what this component does is it returns the names of the sheets in that Excel file that we were looking at before. And now I can just pass this in to my read component, and it's going to read those pieces of data. And so let's say I want to grab out the column points. This is now creating columns based on the location of those coordinates that I pulled in. And so we can then continually dynamically read that if that information updates. And the way, without going into too much detail about it, the way I'm building those columns is also some of our structural components here that are taking a required load for those, and then a regional compliance code. Because I'm working in Australia here, I've said that I've got to meet Australian standards, and then it's giving me a base sizing for those columns. So yeah, I think I'll wrap it up there. It's just conscious of time, but there's a little demo of what the kind of stuff we've been embedding and capturing into the Nodebox library is. Do you have anything else on to add, Marco? No. Cool. Okay, that's all from us. Thank you for listening, guys.
Thanks, Will. Thank you, Mirco. So now for questions, anyone in Auckland would like to ask anything to the guys about the notebooks? Right, I have a question from my side. So it looks like there's been a lot of work put in there. So there is the whole system set up on how you develop in those nodes, the nodes developed for different practices. But maybe if you could say a little bit about how this started, and like how was it if someone wanted to create their own library or package, what advice would you give them when you're just getting started with something like this?
I would say create a GitHub account and start with something very simple and achievable to understand how the process of create node works and the deployment of the package works. And from there, that you have your what we call it generally our minimal still thread, so meaning from start to the end it works, you start to increase and build it. This is pretty much what we did. So we started from a super simple nodes that they were Excel reader, and we explained why we started from there, because we believe and there are many Excel node for Dynamo or Grasshopper, but most of the time they don't work or they are not updated. And so we decided to start from there because we were, for us, the point to explain the value of the library, meaning we can constantly keep it updated, this sort of node, if something changed, for example, in this case, from Microsoft and Excel itself. So yeah, we started from there, very minimal. We demonstrate the value, and after that we start to increase the dimension of the library and the complexity of the library, how to package the deployment and make it accessible to all the company. Another things online, there are a lot of resources for Grasshopper and Dynamo, so you can find many information online on how to start. And this is what we did from the beginning.
Thank you. Do we have any questions from Wellington?
Yes. So I think you talked a lot about the integration deployment cycle of the code itself, but say I'm a new starter, I want to contribute into this library. Like, what does engaging with this, like as a new starter who wants to add a node to your library, what does that process look like?
So first entry point is the website, where we listed all the information for a new developer to understand the complexity of the project, where to find the information, how the development process happened, how we review the code, and from there, the team is available. There is the team channel. You can just connect with us directly, and we help you eventually if there are problems on setting up the solution. And the next step is go to GitHub and look on all the issue that we have and pick one and start to develop. From there, when you are ready, you just open the pull request and you start to review the code. This from the side of the developer. If you are not that developer but you have an idea, we have, for example, in our website, this button here, feedback, that goes in this page where you can leave an idea with a description, and this is trigger an action that create a GitHub issue in our repository that we can pick and connect it to you, asking more information, or if everything is clear, we can start to develop the solution that you require. Or otherwise, again, you can jump in the team channel and we have a dedicated channel that is for feedback or ideas, and just type in something there, and we will try to develop.
Oh, thank you very much.
I have a couple of questions.
Yeah.
So with the Dynamo side of things, are you developing whole graphs that you're hosting in Nodebox, or are you just specific nodes and Nodebox is sharing like a package of nodes that people use to build up their own graphs?
Yeah, the second one. So Nodebox is a series of custom nodes that are useful for expanding your graph. And so what we do is potentially we see there are some graph that they can be wrapped in a node, and so we take all the logic of one graph in a node because that node can be part of something more complicated as a level of a graph and be reused. But yeah, generally, is a custom node. So think about every node that Dynamo or Grasshopper has. We just expanding capability that there are not provided from out of the box, and we are embedding the knowledge that we have from other project or teams that can be reused across different next project and future project.
And then just to follow up to that as well. So do you have in-house a development team dedicated to development and programming of these things? And are you writing in visual code often, or are you writing in actual programming languages for some of these nodes like Python, C#, etc.? So
the nodes are developed in C#. So because to write the node, the nodes are compiled and so they need to be writing code. We are using C#, and the idea is, on the roadmap, the idea is also to expand for Python. In that way, we can also bring even more possibility for our user to provide other solutions. And in terms of the teams, the project is in a sort of way for a big company as MacDonald is quite young. It has just 2 years of is just 2 years old, and so next year, if everything goes well, we should have a more dedicated team. So developing constantly on the project.
Cool, thank you.
Yep. So I see we have a question in Auckland.
Who are your main users? Architects, engineers, just in-house?
Yeah, main users are our computational designer or computational engineers in-house. And they, you know, in the future, we want externalize some of the packages, and so externalize for a computational designer, engineer, or architect, but external from MacDonald.
Thank you. My name is Dipendra. A wonderful presentation to Willem and to Alex also. Thank you so much. But what I see is that what you actually showed in the example is just the tip of the iceberg, right? Because the complexity of the results that you have actually shown in the presentation that Alex showed in the previous one, a lot of parameter analysis has been done. So I think the way I look at it, this is a work in progress, right? The Nodebox that you are putting up is a work in progress, and it is complementing to people who are building engineers and simulators looking into how we can improve the building performance. I just I was just wanted to know, because you mentioned something about well-being. So where is that being captured in your overall those scripts that you have done, and what are the domains that you're taking into account for looking into well-being? Thanks.
Sorry, the question is for Alex or for us?
It was for both. Yeah, I think maybe it's more for Alex, but Alex, are you still on the call?
Yes, I am, but I'm sorry, I struggle to understand a little bit. So
Yeah,
if maybe the key question is repeated, would be appreciated.
Sorry, yeah. So just to keep it short. So I saw that you have a well-being component in your output, right? There's a component of well-being, yes.
Yeah.
So what is that? How do you define well-being, and then what are the key things? Like maybe are you talking about natural-based systems? Are you talking about daylight? Are you talking about views? Are you talking about thermal comfort? What is it? So that the measurable and the unmeasurable gets connected. Thanks.
Yeah, well-being is complex, as you mentioned, all of it, and depending on the project, the priorities would be different, but it's including everything from indoor environmental quality, so it's daylight, overexposure, thermal comfort, and also we started analyzing it outdoors as well, and urban heat island analysis, outdoor thermal comfort. This is all well-being. Maybe we covered it under one word as one output, but it's actually way more complex, and it's not just one thing.
Does it answer your question, or?
Further it, to spill the beans, and then even go even deeper into, because that's the crux of everything that we do. If let's say a housing project doesn't conform to it being supporting health and well-being, then it is a failure, right? So I think it is so much important that we develop the parameters and say, yes, this is for livability and this is for well-being. And then that way, I think even the end user, like if I'm the builder and then somebody is like, yes, my priority is looking into well-being. So can you actually tell me from which of these parameters I'm actually reaching to my goal? So, it's just a feedback that I'm providing. I think so. Thanks.
Thank you. And just one additional point is that I wouldn't separate well-being from good design, because if the space is not comfortable and not healthy, then it's poor performance, then something went wrong during the design. And unfortunately, some regulations are not looking at this quite yet. Therefore, we're trying to overarch the minimum compliance and say, converted from the financial perspective and how well-being and health can, especially in commercial space, it's just easier, can bring more money to developers because they don't really care about well-being, to be honest.
Thanks, Alex. Anyone else have a question? No, right. Well, thanks, Alex, Mirco, and William once again. Some great presentation, and Yeah, so looks like no more questions from our side. I'll just share the last slide before we end the presentations. So yeah, so here you can also see a QR code for anyone who would like to connect with Mirco. So yeah, a chance to do so. And now
Again,
that's
the link is wrong.
Sorry?
Sorry, the link is wrong.
Oh, sorry. Well, then it's something that I'll update afterwards. But yeah, you can see the name, and I'm sure you'll be able to find Mirco by his name on LinkedIn as well. Yeah, I can see. I think the QR code should be right. I did not update the link below. Well, thank you guys. And we still have some pizza and drinks left. So let's move back into the hallway and continue building connection and socializing. Thank you. Thanks,
Thanks, everyone. Have a
Wellington.
good day.
Thanks, everyone.
Do you need to do another safety?